Yes, good morning. Thank you very much for being here. It is a great pleasure for us just to be here presenting Waterproof. The idea of this workshop is to present and introduce to you Waterproof. That is a new tool that we have developed for nature-based solutions investments and to look at the return on investment for these solutions. You will see that this tool is fully web-based and web-based. And the idea is to save time in terms of the requirements to look at the pre-feasibility of a nature-based solution investment. So I'm going to start very quickly with our agenda, presenting our agenda. This is a workshop, so that's the reason you are organizing the way you are, with groups. So at the beginning, we're going to have an introduction to Waterproof. I'm going to talk about a little bit about how we designed the system, how we developed the system, and some conceptual elements that we have developed for the system. But of course, as you can imagine, we have many details about these kind of tools. So good news is that Waterproof is fully documented, so you can go into a section in the web page that we have called Knowledge Bank, and you will find all the information of all the things that we have developed in that section. And I'm going to show you that we also published a paper. So it is a scientific paper that it is peer-reviewed, just with all the things that we have developed for the system. So it is going to be a very short introduction to Waterproof. After that, with me is also Pilar Galindo. She is the developer, the software developer of Waterproof. So she's going to show us a step-by-step demo. The next thing that we are going to do is just to have you into the system, just looking for some results. This is going to be like a practical part of the workshop. You're going to be able just to go into the system, look at the results. So these results are associated with the case study that Pilar is going to configure. So you will have the opportunity to interact directly with the system. At the end, the idea is that you can share your experience with the tool. As you can imagine, this is the first version of Waterproof. We have an entire line of development. So we are really interested in knowing how you feel the system, if the interaction was okay, if you are expecting other kind of information. And this is a great feedback for us just to continue improving in future versions the software. And at the end, we are having some closing remarks. We are going to have an online training for Waterproof, so we are going to advertise that also at the point. So yeah, I'm going to start with the introduction to Waterproof. First of all, my name is Carlos Rogelis. I work for the Nature Conservancy. I'm leading the conservation program in integrated water management resources for TNC Colombia, and I'm part of the development team of Waterproof. As I said before, Pilar is also with us. She is the software developer of the tool, and she's going to show us the step-by-step case. With us is also Naomi and Max, that they are going to help us in the groups for the practical component of the workshop. They are also working for TNC. So just to introduce Waterproof, this is a software developed by the Nature Conservancy, with the idea to have a tool for a high-level ROI assessment designed to provide stakeholders interested in nature-based solutions with a pre-feasibility indicative assessment regarding NBS potential. So at this point, I just want to highlight that Waterproof is intended to be a pre-feasibility tool. And this is important because I'm going to show you that we are using, for example, global databases. And we recognize these limitations. So we recommend to use the system as a pre-feasibility tool. It is not intended to replace any detailed analysis. For detailed analysis and for detailed design, you usually need like a specific data, local data, and you're still going to need it if you want to move forward with the design phase of your watershed investment program. Waterproof is a global tool. So that's the reason to have the entire planet in the screen. And we have incorporated into the system many different features or capabilities. So at the beginning, you can locate your city to do the analysis. The idea to have the city is just to organize the information in the system. As you can imagine, to have this tool for the entire world it's a little bit complicated, and you need a method to organize the information. So the way that we organize information in Waterproof is through the location of the city. You can also configure a water intake and the pre-treatment that you have there. And the idea here is just to have the system very flexible to incorporate different kind of infrastructure that are part of the water intake or the pre-treatment, right? So we have incorporated, at the moment for this version, 15 different elements that you can incorporate as part of your water intake. Pilar is going to show us that it's just a matter of drag and drop in a panel, and to connect the different infrastructure elements to have them able for the analysis, right? After that, you can select or create your MBS. We have, at this moment, configured 5 different MBS that are preloaded into the system. They are forest conservation, active restoration, passive restoration, agricultural best management practices, and silvopastoral systems. Those MBS are quite common to use in our context, especially in water funds or watershed investment programs, but the system is not limited to that 5 MBS. You can create your own MBS, and it's going to be available for you if you use the system, right? Next thing is that you need to configure your drinking water supply system. And here it's important to highlight that the first version of Waterproof is very focused on drinking water supply systems. The system is flexible enough just to incorporate other kind of infrastructure, but for version 1.0, we are really focused on drinking water supply systems. So you have a method to define your drinking water supply, your drinking water treatment plant, right? So the system can predict in some way, according to the water quality in the river and the regulatory measures that you have to have in your drinking water plant for the delivery of water, what kind of treatment train is most appropriate. But it is also flexible in the sense that you can turn on or turn off the different treatment trains, right? You can also put all this together in a module that we called create a case study, right? A case study is simply the joint of the water intake with the drinking water treatment plant, with the definition of your nature-based solutions, with the financial parameters also to have the analysis and the ROI calculation and estimation. And at the end, well, you can analyze your outputs. We have included in the system all the capabilities to share the results, compare results. You can download it. You can have a PDF report also. But the idea was to have a very transparent tool. So you can download all the information there. You can explore by yourself in ArcGIS or in a GIS software all the results, all the information is available there. We have incorporated also all the step-by-step calculation for the user to be reviewed, right? So just to bring some context about the challenge that we are having. So at this moment, we all know that watersheds are being degraded around the world with dire impacts in water security. We know that nature-based solutions can contribute to the protection or restoration of these degraded watersheds, right? But the problem is that if you want to demonstrate a positive ROI of these nature-based solutions, usually it's very complex and time requirement, right? In our experience, to have a pre-feasibility analysis of an MBS portfolio with the ROI analysis, it can take like 6 to 8 months, right? And it's quite expensive to have that kind of information. So at the pre-feasibility level, we wanted to develop a solution that we call Waterproof, right? So we reduced the time from 6 to 8 months to just a few minutes, just to have an idea of the MBS potential in your watershed, and to be able also to calculate and estimate an ROI, right? Again, this is only as a pre-feasibility analysis, but we have found that it's really useful if you want to look at your basin and to look at the potential of your nature-based solutions portfolio, right? So at the beginning, with the idea to develop this tool, we incorporated some concepts for the development and design of the system, right? We wanted waterproof to be fast. The idea was to have this estimation of the ROI very quickly to save time, to save money, right? It is compelling, is really a transparent tool. You will find all the documentation, all the things that we have incorporated into the system are available, and also with this scientific paper that we have published. It is customizable, so you will find in Waterproof that we have preloaded many databases, and we have also preloaded cost functions and all the parameters for the analysis, but it is also customizable in the sense that you can modify all these parameters, you can incorporate your own cost functions, you can customize your drinking water treatment plant or your water intake system or pretreatment system, right? So it is fully customizable. It is multi-currency, so we have all the currencies in the world. We read this from a database, and you can specify the currency for your analysis, and also you can combine different currencies, right? Waterproof queries all mornings a database for the exchange rates. So the idea is that the system is fully updated all the time with the currency exchanges. And at the end, you're gonna have like all the things updated for your analysis or for your financial components. And well, finally, we wanted to have it free, and that was important for us. All the costs are supported by the Nature Conservancy at this moment. So the web page is free to access. The only thing that you have to do is to register into the system if you want to run your analysis. But it's completely free, right? All right. So at the conceptual level, as I mentioned it before, we are using global databases. That was really challenging to find the correct databases, global databases for our analysis. But at the end, we have a full package of databases in raster formats and in alphanumeric formats, just to have all the information there that we think is the most appropriate for the analysis at this moment, right? So the entire plan is like that. We have incorporated 2 different softwares for the analysis at this moment. Those are desktop software, so part of the challenge in the system was to have this software for the web environment, but yeah, we have successful procedure with this, right? And we incorporated these 2 software that are developed by the Natural Capital Project with the Stanford University that are called RIOS and Invest, right? RIOS is for Resources Investment Optimization System. So RIOS allow us to have the cost-effective portfolio for nature-based solutions. So it is a tool that was developed by Stanford University that uses biophysical parameters to find the places where your MBS can be more successful, right? And you have their cost-effective relationship there. So RIOS suggests a portfolio where you can look at the watershed and the location of these nature-based solutions to have the most cost-effective effect, right? And on the other hand, Invest allow us to look at the changes in ecosystem services that are associated with that, with the implementation of the nature-based solutions, right? For this version of Waterproof, we have incorporated 5 different models, Invest models. We have incorporated the annual water yield model, seasonal water yield, sediment delivery ratio, nutrient delivery ratio that can calculate nitrogen and phosphorus, and carbon storage and sequestration. So we have incorporated also a module that we will see later that is also available for carbon calculation, right? So using these modeling packages, we have like the changes in the ecosystem services, and the idea is to monetize these benefits, right? And we do this using something that we have called cost functions. And a cost function is the relationship or the mathematical equation that can relate the operation and maintenance cost of the infrastructure with the changes in the variables that we are modeling. In this case, is flow, sediments concentration, nitrogen concentration, and phosphorus concentration, right? So we can look at the effect of the changes in ecosystem services and the benefit expected in the water intake system and also in the drinking water treatment plant due to the change, for example, in sediments. So we can predict, for example, if you reduce your sediment delivery ratio in the basin, how it is going to affect, for example, the use of the chemicals in the flocculation process in the drinking water treatment plant. That's the process that we are using in this case, right? And at the end, we are having the ROI calculation, where we put all this together with the global cost functions, and we can calculate the ROI because we can also calculate or estimate the cost of the implementation, maintenance, and opportunity costs associated with the implementation of the nature-based solutions, and we can relate that with the benefit, with the monetized benefit that we are going to have in the system. It is also important that for the analysis, we have incorporated also a historic climate, but we also have 6 different climate change scenarios, right? 3 scenarios RCP 4.5, 3 scenarios 8.5, and the idea is that with the system, as soon as you get your case study configured, you can modify very easy to look at the climate change scenario and to look at benefits in there, right? So yeah. Very quickly, as I mentioned before, we have published this paper. This is a peer-reviewed paper where we explain all the details about the system, how we configure the equations, all the technical details are there, and it's a peer-reviewed publication. So it's just to generate trust in our system and the conceptual process that we have done in this case. Currently, we have more or less 120 active users that are configured cases all around the world. They are from 27 different countries, so the system is being used at this moment. And we also can provide some assistance in some case studies, right? We have assisted cases in these countries, Colombia, Lesotho, Greece, Mexico, right? But the idea is that if your case study is really a big one, right? We can offer this kind of support and assistance to look at your case and to create the case in waterproof. So I think that's a general introduction to the system. Of course, with the demonstration with Pilar, we are going to have like more details on things on how to configure the system, how to use it. As I said, the idea is that we are going to have now with Pilar a demonstration step-by-step on how to configure a case study. We are going to use in the groups this case study to explore the results. So be very focused on the steps that Pilar is going to show us. And yeah, thank you very much.
Okay, thank you very much. Like Carlos says, my name is Pilar Galindo. I am system engineer. I worked for TNC like analyst, system analyst. I'm going to show you the website, the landing page of Waterproof. You can enter there with this URL, waterproof.org. I want to show all the information that is available in this page. The system is completely web-based. It uses cloud computing to run mathematical modeling, like Carlos says, to offer to you a cost-effective portfolio of nature-based solutions, and do analysis related with the benefits of ecosystem services to offer to you analysis of the return on investment. So this is the button more important because it's the point to start your case study, but we invite to you browse the web page where you can find some information to understand what is a case study, what is the information at the global database that we use. And for example, you can enter here and consult all the an example that we want you use like a guide to configure your own case study. Is very detailed, so we invite to you. Again, we highlight that the system is fast, is compelling, customizable, and free. In this section, if you click here in the button, we explain all the steps to configure the case study. But in these buttons, we can understand the process. You have to find your area, your city where you want to do the case study. You have to keep in mind what is the nature-based solution that you want to implement. The next step is locate the point of the water intake, some information I'm going to show you, and define the treatment plant infrastructure. With all of this, the last step is to configure the case study. Is the point where you ensemble, you join all the information, the system runs, and is going to return to you some analysis or results. And this is the point that Carlos says the knowledge bank is a set of articles where you can find all the concepts that we use, the cost functions, the equations, a little resume of the explanation of the models that we use. So in this webpage, I think we put all the information to be very transparent and share with you all the concepts that we use. So we are going to start. When you register, you have to click here in this button. Like Carlos says, these systems work for all the planet. But we are going to work with Bucaramanga. And look at the system to identify what is the currency of that country. We are in Colombia in this point. So we can click here, the case studies list, and this is the way all the system works. You have all the time this menu that accompany to you, that guide to you in the 3 steps to configure the case study. You always have the city where you are doing your analysis, and the system show you the analysis that had been configured for this city. All the time it is keeping of the information. So to do the case study, you have to keep in mind that you have to configure your water intake, your treatment plants, and with that information we have to join to make the case study. So we are going to start doing the water intakes. If you click here in current list, the system behavior is the same. You can see all the information configured. We are going to create a new water intake. So when you are configuring the elements of the system, you can see that we have here like a wizard that explains to you what is all the steps that you need to configure the element. So we are going to put a name. The description, like you recognize your water intake. Description, nothing but special. It's better that you keep in mind what is the water source that is giving you the water, like Rio Negro, Frio. And you have to define the exactly point where is your water intake. There is the, two ways to put this information. You have to put, you can put this pin, and you can move it if you want, yes, for example. But if you have the exactly point, you can write here the coordinates. And you ask the system use your coordinate, and you have to click on draw base. So in this moment, the system uses an algorithm that process the digital elevation model and analyze the flow direction and give to you a recommendation of the area to implement your NBS, okay? So this is the first step. We're going to click on next. This is the step where you have to define the elements of your water intake. We have like a reservoir, pumping, other type of reservoirs, site intake, all the elements that you know more. We are going to use this one. We are going to use the descender, and all of the water gives the water to the treatment plant. So you have the elements, and if you see the element by default is the river, where you take the water, and you are going to do the connections to the elements like this. Only drag and drop your mouse. And you have to define what kind of connection is in your infrastructure. The first one is the extraction connection, where we take all the water from the river. We are going to use this pipeline to use this to connect this element, and for this one again the pipeline. But you have to define how much water do you consider in this scheme. So if you are if you finish to draw your infrastructure, you have to validate the graph. The system checks to you the element, but it's important that if you click for any element, you can see the cost functions that is used to calculate the return on investment. So we have now our scheme. So I'm going to click on next, and the next step is to inform to the system what is the water demand. In this point, you define the analysis period. We are going to use 30 years. And you have to put the extraction, the water extraction, in the initial year. We are going to use this number. And the final year. Okay, let me see. But it's difficult to you write all the demand for each year, so the system helps to you to generate the information. We have methods to help to you to define this demand. In this moment, we are going to use linear interpolation. So we have indicative demand for the analysis period. This is, I mean, it's important that you keep in mind that you want to do your projects, your NBS implementation for this number of years. So we are going to click on next, and we are in the last step, where the system asks to you to confirm the area of the analysis. you can modify with these vertices the area, maybe because you are only interested in a specific area, but the system shows to you that it is the recommended area. So we are going to validate the polygon, and we are going to save it. In this moment, the system is running for first time invest models. The system in this moment is analyzing how is the sediments, how is the nitrogen, the phosphorus concentrations, because this is the element to recommend to you the treatment trains. That treatment trains is going to have also a cost, function cost. So in this moment, the system is working and return to you to the list of all the water intakes that you have. So we done the first step. We are going to do now our treatment plant. Carlos, do you want to complete something?
Probably just to mention that at that point, at the first step, if you notice, we can delineate the watershed and with a specific point of the water intake, right? And this is because we incorporated into the system an algorithm just to analyze the digital elevation model. So we don't have preloaded watersheds in the system. It is all analyzed using cloud computing. So at the point that you set your water intake, the system is going to resolve the flow direction, flow accumulation, all the things necessary just to process the DM to establish to delineate the watershed. And as Pilar was saying, that was the first run. You can notice that it's quite fast, just to have the run of Invest. It took like 1 minute or something like that, just to have the first run in the current state, the scenario, right? Just to look at the water quality at the point of your water intake. That was the price.
So in this moment, we are in the second step, that is to define your treatment plan. You have to put a name. Congrats. You can enter your description, and in this point, you says to the system that you are going to receive the water from the water intake that we done. So we have in this moment all of this water intake. I'm going to use
It's the second one.
is the second one? This one? Okay. And the system, when I confirm the water intakes, the system analyze and recommend to you what is the treatment train. For Bucaramanga, the system identifies this is the process to treat the water with this, but we are going to use, how do you say, Carlos?
Yeah, well, you can notice that the system here, well, we have in the system like many different treatment trains, right? With quite commonly used in the world, like quick mixing, slow mixing, sedimentation, filtration. But we also have like the membrane train. And that it is fine because in this city, the system predicts that we need to have membranes to achieve the requirements for water treatment. But in reality, this is a real case, and in the city in Bucaramanga, it is a conventional treatment process. So we don't have membranes. So you can customize that just when checking the box, that because as you saw, the system is suggesting to have membrane treatment, but you can check the box, and that's all you need just to complete that.
Give me a second. So if you want to analyze the technologies that are available for your treatment train, you can click on these elements, and you can identify what is the technologies recommended. But you only have to check what is the technology using in your reality. So if you are agree with the train, you can save the treatment plant. And again, the system is gonna return to you to the list, to the treatment plants. Give me a second, please.
While the system is loading, you have the retained here. Is it now retained in the water, or is it retained?
Sorry?
The retained here. So nitrogen retained.
Okay, yes.
Is it retained in the water, or is it retained?
In the treatment ring, I mean, in the process. So, for example, for sedimentation, it is like the percentage that you expect for sediments to be retained in the sedimentation process that you have.
Okay.
So, yes.
Now another question is still loading. You had earlier in the first water intake, you talked about descender.
Yeah.
I don't know, what is a descender?
A central.
Oh, a center.
Yes.
And then the linear interpolation is what?
Yeah. When you are going to define like the demand that you're going to have year by year, you can do it into the system by two ways. You have a manual table. If you know that your demand in the year 1, 2, 3, 4, you can enter it manually, right? But if you want to have like the initial year of the demand and the last year for the demand, for example, in 30 years, you can use interpolation method just to have year by year your demand. That's it.
Thanks.
So when we have the treatment plant, the process consists to join, to ensemble your case study. We are going to see this example. The same way you have the wizard to define your case study. You can use or you have to put the name, a description, and you have to say to the system that you are going to use water intake and your drinking water treatment plant. The system can be configured to analyze the carbon market benefits with these numbers that comes from a global database also. The next step is to define your portfolio objectives. We have identified this. If you want to work in the erosion control for drinking water quality, erosion control for reservoir maintenance, nutrient retention related with phosphorus or nitrogen, flood mitigation, groundwater recharge enhancements, and base flow. And the next step is define the modeling parameters related with information that is necessary by Invest. So this is information that advanced user can change. If you don't have any specific information, you just can't click on next. The next step is to define the financial parameters. This is the point where we are joining all the elements. So the parameters here is related with the annual platform cost per year, where you can enter your budget related with the personnel, office costs, travel expenses, all you need to implement per year your project. Also, you can to enter the transaction cost and discount rate for the return on investment analysis. So again, all of this information comes from global databases, and the next step is related with the selection of your NBS that you want to implement in your area. So like Carlos says, we have this preloaded related with active restoration, agroforestry, forest conservation, passive restoration, and silvopastoral systems. You can check, but the system has a functionality when you can add your own nature-based solution. We are going to see it. The next step is related with the analysis parameter, where you confirm what is the analysis time period that you want to work, the implementation, the period, the implementation NBS period, the currency that you want to do your analysis, the climate scenario, and this budget that is required by year. In this case, we use these numbers for dollars, and when you run the case study, the system is going to show you this page where you can find all the results and the analysis of the return on investment. And this is the section that we are going to use in the next exercise that you are organized in groups to explore the application. So if you are agree, please do groups, and we have materials to work in the web page.
So, what is it? Yeah, well, the idea now is that we are going to have like a group session. So that's the idea. If you can just please join a group. And the idea is that we are going to explore the results of this case study. We have in the tables like a little guide just to look after some questions and some information. We are going to have like one computer per table, so we can just explore the results of the case study. Just to notice something that probably is good for you to know is that when you create a new MBS, you're going to have like this format, right? This MBS is just going to be available for your user, right? That's important because it is not sharing with other users because, well, you can create many different MBS and it's going to be a mess into the system. So it is just for your user. And here in the creation of a new MBS, you can find, like, you have to put information about the name, a description, but you also have to characterize the biophysical benefits of your MBS. And this sometimes is quite hard because we have been working this for years just to identify like the time to get the 100% benefit and things like that. We know it is hard, but it is needed for this system, right? And as I mentioned it at some point, you can define like unit costs, maintaining costs, and opportunity costs, right? And it's the way to characterize the cost of the infrastructure, of the nature-based solutions infrastructure. So it is important also to have that kind of information. And at the end, as we are using the RIOS framework, if you remember, that's our software to define the MBS portfolio, right? We can have like different kind of transitions for this MBS that are defined in RIOS, like keep native vegetation, revegetation assisted, agricultural vegetation management, ditching, fertilizer management, and pasture management, right? So when you select this kind of transition, you are also going to be able to indicate to the system if what is the effect of the MBS in terms of land use change, right? And that's the way that we are using in the system to have the simulation in the nature-based solutions scenario. And this is important because we are comparing in this kind of analysis for the ROI, we are comparing future to future scenarios, right? We are not comparing the current scenario with a future scenario with MBS. We have found that the best way to do it is to compare the future scenario as a business as usual scenario. For example, if you want to analyze the system in 30 years, well, we are gonna predict, we have a method in the system to predict the land use change in 30 years associated with a business as usual scenario. But we can incorporate also there the future in 30 years with the MBS scenario. So we can compare the results in these two scenarios just to have the ROI estimation. So yeah, I mean, that's only additional information. As I said, if you want to, well, especially that role, if you want to join a group, we can just start with the exploration. The idea is just to interact with the system, and we'll look at the results.
Carlos, utiliza waterproof CG.
No, Pilar, pero es que no
Pero
está.
ahí está.
Pero Pilar,
Mira.
no terminaste el caso.
Pero este es un antiguo el que me mandaste a
Pero ¿por qué
hacer.
no utilizamos el bebé?
Pues
Bueno, si
cualquiera,
quieres úsalo, pero
este
entonces
está
si
bien.
quieres únete a la,
Pero
a
voy
la
a,
mesa
voy
de
a
ella.
levantar aquí a ver qué fue lo que pasó. Que sí quedó bloqueada la...
Sí, sí, pero tenemos que seguir con el taller.
Bueno,
No,
pero es
ojalá
este.
luego.
¿Ya lo puse público?
Yo voy a utilizar el de no importa. Pero dale con el grupo de atrás. Fue muy interesante. Si quieres, ahora más tarde lo hacemos. We're developing Colombia as a global. Yeah.
Carlos, we want to go to Germany to go.
Yeah, you want
Just suppose this was sports. The next level is already different. This thing goes through. So the next level would be higher.
Quería registrarme y no lo pude hacer en el celular para abrir una cuenta de Argentina.
Ok. Espérame, reinicio el servidor.
Sí.
Y ya te busco. Dame un segundo.
Yes.
And so here, okay, you have the one that we are using is this one. So you have to sign in into the system. So you're able to. What is that? Yep. Yep. No. Yep.
Esto, ahí otra vez, miramos acá.
So when you are just registered and you are part of the system
Dame un segundito que levante, entonces acá le decimos logout.
Ahí está.
Y yo creo que ahorita sí te va a dejar, seguramente
acá.
estaba ahí raro. Ay, register. Dale, ingresa tu email.
So your balance here, everything is the same, but you are not happy with your discount rate.
Ah, no, está distinto acá. La Y. El teclado, la Y, ¿dónde está? Acá.
¿Aquí?
Ah, está distinta.
Ah, yo sí decía, pero porque yo también.
Está distinto, ¿no?
Sí, es que este es alemán.
Ah,
portátil
claro,
alemán.
portátil alemán, muy difícil. Initials son las iniciales
Sí, tu
propias.
nombre.
Yes. The benefits in this case are coming from the segment reduction because you saw that it's from 80 something percent. The things that we are seeing in nature-based solutions is that probably the effect on water quality is more.
Password es el que yo elija, ¿no?
Sí, trata de que quede una mayúscula,
Sí.
un carácter, un número,
Sí.
lo de siempre.
Lo de siempre.
With nature-based solutions, we want to have more water, and apparently it's not like that. We should be careful with that. So it was intended to have a special.
¿Ves? No me deja nuevamente.
Ah, ¿ya te habías registrado? ¿Sí?
No,
¿Pero ya le habías dicho?
sí,
¿Antes?
pero password de
ingresar.
nuevo.
Tú ya habías intentado. ¿sí?
Había intentado y no me había permitido.
O sea, había pasado lo mismo,
Exacto.
¿cierto? Entonces ya,
Sí.
debe ser que ya te tengo. Espérate un momento.
¿No ves? Mira.
Sí, debe ser que ya te cogió.
A ver.
Seguramente acá. Ya te confirmo, ya debe estar ahí
A ver.
creado. ¿Cómo te llamas?
Cervera. No veo, ¿no?
Acá.
¿Me has visto?
En la 2.
Esa, sí. Mm.
Déjame, ¿puedes mirar tu correo a ver si ya te llegó un saludo?
A ver.
¿No llegó nada? Ok. Entonces intenta ya
A ver en
ingresar.
spam.
A ver. No. A ver, intenta, ingresa
No.
aquí. No. Ingresa aquí ya con tu usuario. Porque dice que ya estás activo.
Arroba point. Ah, sí, ahora es el usuario, ¿no? El password.
Estaba mirándola. Ahora sí verifica tu
Ah.
email address, a ver.
Vamos a poner el normal.
Tiene que estar llegando por ahí, atravesando el Pacífico.
Sí, atravesando. Data no, ¿no?
No, es waterproof.
Porque ya van a ser las 12.
¿Cómo así?
Claro.
Vamos a iniciar.
Ah, para ya intercambiar, ¿sí? Déjame ya ahorita te busco entonces,
Ok.
porque ya debe estar.
¿Sí? ¿Funcionó?
No.
¿No?
Ha llegado.
¿No ha llegado todavía el email de verificación? El servidor está un poco lento. Pero también en caso tal, si quieres nos dejas tus datos
Ya los tengo,
y
ya los tengo. Yo
verificamos
le aviso.
para eso.
Ah, ok.
Perfecto. ¿Sí? Ah, listo. Solo da clic acá. Exacto.
Y ahora pongo
Ya,
el correo.
ahí puedes, y ahí ya puedes logar. Vale. Okay. Yes. Thank you very much. I'm looking that you're having a great time. But yeah, well, we are running out of time. So we really want to hear from you, from each of the groups, like your experience, if you have feedback for us. So we're going to spend like 5 minutes to do that. And at the end, we're going to show you that we are preparing an online training on waterproof. So that's also important for us. But please go ahead with your feedback. I don't know if you want to start, please.
So I think the tool is impressive. It's amazing that it's a free tool and that we can all access. So I think this is quite an advance towards the direction we're really looking forward. So congratulations on that end, and I'm really happy to see that this is a Colombia development. So very proud. But on the other side, I just have like a slight suggestion. Maybe it's like when we see the return on investment at the beginning, it's quite impressive. Yes, it's 23%, or like 23 here, 27% there. So it's like quite an important return on investment. But then when you like see what is your main concern, which is water quantity, then you find out that it doesn't have like that impact on the water quantity. So I understand that you have a positive return because you have another benefit coming from sediment retention. But I think you should give the client, the customer, the option to weight the benefit by the expected return or the expected benefit they want.
That's
So
good.
maybe that could consider.
Great. Thank you very much. Thank you. The other group.
Yeah. So yes, again, congratulations on this tool, and I think especially it takes from a lot of open database as well. And I don't think we completed the exercise by ourselves. We are on the way. We are trying to fill in and all that, trying to look at the numbers and yes, the 23% is impressive in the beginning, and then the only thing that we are kind of thinking about is how do you use this in terms of without any expert support in terms of the values that you have to enter, right? So you might need inputs from various people. It could be the cost, it could be the technical and all that. So how would one do that? Is that a question that we have? Like, because honestly, I have not worked on a database solution, so I might not know that. But I am coming from a tool perspective, so I'm just thinking about how how to collaborate and work on this. Because especially you said it's a pre-feasibility, right? It's like once you know the technology and you want to do it, you can pinpoint to a particular technology and go into details of how limited you, how much it is going to cost. So that's where our understanding is. If you can elaborate on that, it would be good. Or if I understand
Thank you.
I have another comment. We didn't discuss this really, but so you pull quite some data from global databases. Um, what is the reliability of the data? I mean, I can understand some data is generated through satellite imagery and it's quite similar everywhere, but some of the data is really a compilation of local data, and
Mm-hmm.
in certain countries or certain areas, the reliability is much lower of those databases. Is there a possibility to include some kind of index or
That's good.
to show, for example, I mean, if I look, for example, at certain areas in Africa, in Ethiopia, maybe the reliability is much lower than, for example, in Europe or here in Germany, where, yeah.
Yeah, no, that's great feedback. I think we have an assessment of the reliability of the data. So I think it is just to put it like visible into the system according to the country that you are working, right? And that's great. Thank you. Yeah, thank you very much. And finally, that's great. Oh yeah,
also the cost function that you want to put, is it also dependent on the area or is it
yeah.
different? Okay.
Well,
How do you arrive at it?
yeah, let me clarify that. The construction of these cost functions was really hard, as you can imagine, because there is no like homogeneous data around the world for this. So we mainly use different data sources in the literature by published papers and things like that. But at the end, we consolidated all this information about cost functions, and we have a conversion factor for each country according to the economical development of each of the countries. That's the way that we are doing at this moment, and that's the multiplication factor that you can see in the system. But that's the way that we are adjusting the cost for each country through the economical development of this country. Thanks. Yeah, please. Someone?
We were trying to introduce a leaking pipe, but it doesn't work.
Okay, let me check then.
Yeah, so
Yeah.
you get 100% of the water transported. So if you have a leaking pipe, it would change your
Yes.
economics, right? Your return on investment.
Yes, it is. Yeah, let me also clarify that. Well, actually, I had like two good feedbacks from this group. One is the necessity to include in the diagram the diameters and the materials for the pipes. That is a great suggestion, and we're going to consider that. I read write it down. An agent. Okay, that's good. Yeah, just to have it. And yes, the way that we solve that part of the system is through the water quantity and water quality balances, right? So if you introduce there that we are not transporting 100% of the water, but I don't know, 85% because you have leakages, it is going to affect all the balance in terms of water quantity and quality. That's the way it works. So it's just to solve the balance, right? Okay, so just to close this workshop, thank you very much for your assistance. It was great. And we just want to highlight that we are going to have a virtual online training that is going to start on June 15. If you want to be part of this training, yeah, just please, well, just to mention that we are going to have like 3 tutors for the training. I'm going to be one, Pilar is going to be the other, and a colleague of us is going to be another trainer for this course. It is going to be all online. We estimate that it is going to be like 8 hours training, so that we are going to divide in 3 weeks. It is going to be from June 15 to July 6. And if you want to be part of this training, just please send us a message to this email, waterproof@tnc.org, just with that subject, registration for Waterproof online course, and just your name, right? The course is going to be very fun, I promise. We have incorporated like not only the elements for waterproof, but also many videos and technical information about nature-based solutions, water, how to model, how to assess the return on investment for this kind of thing. So it is going to have a very good component in terms of modeling, in terms of general concept, cost related to implementation of nature-based solutions. And of course, we are also having a module dedicated to how to use the system, how to configure water intakes, how to configure drinking water treatment plants, and how to do the ROI analysis. So yes, I think with this, we can close the workshop. Again, thank you very much.